Hey everyone, today we're going to find unknowns and equivalent ratios again. I'm going to show you a few more strategies and you're going to find one that you absolutely love. So, you are going to learn how to use multiple strategies to find the unknown in an equivalent ratio. The first one is to find a relationship. This is what we did last lesson. We noticed that from the known to the unknown ratio, we got way bigger, didn't we? In fact, we got 6 times bigger. So in order to find the unknown, we are going to need to times by 6 as well. So the unknown is equal to 6, right? We've done it. You're awesome at that. So find a relationship now. We're getting bigger, but 6 to 15, there's not a relationship there, is there? Because 15 is not a multiple of 6. And remember I told you you could also go up and down sometimes? But if I look, 4 is not a factor of 6 either. So there's not a relationship side to side or up and down. So the sad news is that finding a relationship will not always work. The good news is that I have other strategies that will help you figure out what those unknown ratios are. So the second strategy that I'm going to teach you is to simplify the ratio, and then you can often find a relationship there. So let's go back to the one we were just looking at. We had that 4 to 6. Can we simplify 4 and 6? Yeah, they're both even. If I put them in a birthday cake, I could pull 2 out as a common factor and get 2 to 3 instead. And then 2 to 3 has a relationship. That 3 is a factor of 15 and it's getting bigger, so I can times it by 5. So I will times this top by 5 as well. And that tells me that y equals 10. You like that? Let's try another one where we can simplify and then find a relationship. On this next one, moving along. There we go. Maybe. Come on, my friend. Where are you? Okay, let me remember what it was. Hold that thought. There we go. Close your eyes. There we go. 6 to 30. Okay. So if we have a 6 to 30 and a 14 to something else, 6 to 14 does not have a relationship, right? But I notice that 6 and 30 do share a common factor of 6, doesn't it? I can divide both of these by 6 and I will get 1 and 5. So now instead of 1 to 30, I have a 1 to 5 ratio. And hey, what do we know about ratios where 1 is one of the numbers? It's a unit rate. Woo woo! I especially love unit rates when talking about equivalent ratios because that means that there will always be a relationship. What do I mean by that? Well, 1 is related to everything. 1 is a factor of every single number. So I will always then be able to find a relationship. 1 times 14 is 14, isn't it? So I'm going to have to do the same here. 5 times 14 is something that I'm going to figure out over here. Is 70. So the unknown is 70. Do you see how that works? I like that one because when I simplify, it makes it so I have smaller numbers to work with. And I like multiplying, dividing smaller numbers. All right, now one more strategy. This slide is supposed to say one more strategy that you might like best. I don't know why it's not showing up on the screen. So in order to explain this one, I have to jog your memory back to when I taught you about equivalent ratios. Remember, one strategy I showed you is that we can cross multiply. 2 times 50 is 100 and 1 times 10 is 10. And I can automatically know that, hey, these are not equivalent. But then if I go 9 times 4, I get 36. 12 times 3, I get 36. Yes, these are equivalent. So when we're finding unknowns to equivalent ratios, we're working with problems like this, where both of the ratios, when you cross multiply, end up with the same number. We're going to use that to help us find an unknown value in one of these ratios. So the strategy is to cross multiply, and I'm going to show you what that means. We are going to cross multiply. 4 times 15 is 60. 6 times y. I don't think I've taught you that yet, but it's really not too big of a big deal. You'll just go 6 times y. Nice, huh? So I told you that both of those have to be equivalent, correct? So both of them have to be equivalent, then it'd be 60 is equivalent to 6 times y. Well, what does y have to be in order for this equation right here to be true? The only possible number that y could be is 10, right? Because then we'd have 6 times 10, which is 60. And then it is true, 60 is 60, cross multiply, and we both get 60, and they are equivalent. So I know that y is the only possible solution. So we just found out that y equals 10. That unknown has a value of 10. Now, here's a cool thing. Not a cool thing, I keep losing all my slides. Wonder what was there. Let's find out. Cross multiply, cross multiply. Oh, what I wanted to show you is, hey, we just did that problem. Earlier, when we simplified and found the relationship, we found that the answer was 10. If you look back in your notes, you'll see y equal 10 and y equal 10 by doing it the cross multiply way as well. So let's practice that again. Maybe. Where did all my stuff go? Look at all these issues we're having. Oh, guess what? I remember I have to use 2 fingers and not just 1 finger. So I'm sliding and it's not working. I changed it, so now I have to do 2 fingers. So let's cross multiply again. Here we have an unknown value for n. What does n equal? Well, 3 times 16 is 48. And 12 times n also has to equal 48, doesn't it? Because they are equivalent right there. So they're equal. So if I have 12 times n, and that has to equal 48, there's only one possible answer for n, isn't there? The only thing that will work is 4. Because then I can get rid of that and get 12 times 4, which is 48. And then we have 2 numbers that are the same. So n equals 4. Perfect. So you can now figure out, or you can now find unknowns in equivalent ratios multiple different ways. I would suggest when you're doing like something important like mastery check or a test or a quiz to solve it 2 different ways, right? That way if you made a mistake in simplifying, when you cross multiply, you can see if they're the same, okay? All right, last summer, Kenyon earned $210 for mowing 7 yards. How much did he earn for mowing 5 yards last summer? Let's take this problem and let's solve it those 3 different ways. Let's try the relationship way first. So I always put money on top, 210, and that's for 7 yards. How much did he earn for 5 yards? I'm going to put the 5 on bottom to match up my 7 yards with my 5 yards. And a relationship here, I can see that 7 will go into 210 30 times, right? Because if I just did 7 times 3, that'd be 21. Add a 0, and that would be 210. So I'm going to times them both by 30. 5 times 30 is 150. So by doing it this way, I found out that Kenyon will earn $150. Let's do it the unit rate way now, where we try and simplify it. 210 over 7 equals something over 5. Simplifying it, if I just get it straight to the unit rate, that means I'm going to divide both of these by 7, and that will give me a unit rate where one of my numbers is 1. So 7 into 210 is 30. So the unit rate is 30 to 1. And do you see why I like unit rates? Because now I can go from 1 to 5. I'm getting bigger, so I'm going to times by 5. 30 times 5 is 150. So again, I found out that he will earn $150 mowing 5 yards. Last one, cross multiplying. We have 210 over 7. That's equal to something over 5. Let's do a D for dollars. So if I cross multiply, 210 times 5 is 1,050. That's going to be equal to 7 times D. Oh, move your face. There we go. Now this one's a little harder. I have 1,050 equaling 7 times D. This is not a mental math one, is it? Unless you know your sevens really well, which I don't. So might have to work backwards on this one and take the 1,050, divide it by 7, and that will give me, a 150. So that means my dollars is 150, which is the same thing I got with my other problems. I got 150 for my unknown here, 150 for my unknown here, and 150 for my unknown here. So as I look at these different strategies, which one do you like best? Which one works for you in the way that you think? For me, finding a relationship is my favorite. Why? Probably because I'm lazy. Look how much work that this was. This really was not a whole lot of work. Okay, but like I showed you earlier in the video, sometimes the relationship way doesn't always work. So it's always good to do that relationship way first. And then if it doesn't work, try one of the other two strategies. If I look at the other two strategies, simplifying is a little less amount of work than cross multiplying. So that might be my second go-to. Here's the thing with cross multiplying though. Yes, it's got some multiplying and dividing, but it will work every single time. So there's a huge advantage to cross multiplying and finding it that way because you know it'll work the first time. Sometimes when you simplify, there's still not a relationship. So there's some pros and cons for you. Basically do whatever works best for you. Okay, I'm going to give you a chance to try that right now. So, whoa, guys, I keep losing my slides. There we go. All right, figure this one out on your whiteboard. I don't care if you try to find a relationship, if you simplify and then look for that relationship, or if you just go straight with cross multiplying. What's the answer though? Well, right off the bat, there's no relationship, right? 8 to 20 doesn't work. 6 to 8 doesn't work. So I'm going to go and see if I can simplify. If I divide both of these by 2, I get not 3, 4, I get 3 to 4, something to 20. And that one will work, won't it? Because that will be 5 times bigger. So if I get 5 times bigger here, I get an answer of 15. So simplifying worked. Finding a relationship didn't. What about cross multiplying? Cross multiplying I know will work because it works all the time. But how hard is it to do on this one? 6 times 20 is 120. 8 times something is also 120. Do you know your 8s all the way up to 120? Ugh, neither do I. That's okay. I can work backwards and I can divide 120 by 8 and get 15. So either way worked, either simplifying and finding a relationship or doing that cross multiplying. That worked pretty well, didn't it? Okay, friends, that is how you can use finding relationships, simplifying, or cross multiplying to find those unknowns. Get a lot of practice in so that trail in your brain can really get paved. Good luck.